when you're using algebra, we can use it to help us solve problems because you can give a letter an unknown value. So whenever you've got a question where it's like, oh, what's the number of this, or you're trying to figure something out, you can make an equation normally and then solve for that, and you can get to your answer. So we'll look at some of those scenarios, and I think they're really good fun personally. A bit of problem solving. It's just a different way to go about it. So John and his elder sister are 4 years apart in their age. If the sum of their age is 42, describe how you could work out how old they are. Now, some of you guys might have a bit of a think about that one. Have a think about it. So they're 4 years apart, and the sum of them is 42. I mean, in my head, I kind of go, well, half of 42 is 21. Then I might be like, oh, so it would be 20, 22, 19, and 23. I kind of go down the middle and do that, and that's fine. Like that's probably the easiest method, to do that. So you can do that. You might go, okay, well, if they're 21, is half of 42, so sort of 22, 20, that's 2 years apart, 23, 19, there we go. That's what they have to be. How we could write an equation to solve it, and we're going to give X, John's age. Okay, so John and his elder sister are 4 years apart. So we're not too sure if John's older or whatever, or younger, but let's just say John is the younger one. So X is John's age. So we know that John and his sisters are 4 years apart. Okay, and we know that the sum of their ages is 42. So let's say if John's a younger one, right? If we're saying John's the younger one, well, 42 would be John's age. And if they're 4 years apart, it'll be plus his sister's age. He's the younger one because it's his elder sister. All right, I didn't pick up on that one. Always got to read literacy. Elder sister, 4 years apart. So he's the young one. So therefore, his sister has to be his age plus 4 years. So you could use this to solve. Now minus 4. So what you've really done is you've taken away the age part of his sister. And now I can divide that by 2. 19 years. So that's one way you could do it. Another way, it's probably the most easiest way to do it. So that's why algebra is really helpful. I mean, the other idea is if you know they're 4 years apart and she's older, and if the sum of them is 42, well, that means that, you could go 42 minus 4. That would be John's age twice, right? Which is 38, which is pretty much what we did here. And then if you divide that by 2, that would equal 19. So we can use algebra to help us solve these problems. I think they're really good fun. So let's have a go at this. So key ideas are always good to have a read through in any sort of math resource. So an equation can be used to describe any situation in which two variables are equal. To solve a problem, follow these steps. Define the pronumeral to stand for an unknown, e.g. J equals John's current age. You always want to try and only have one variable. You don't want to go, oh, let J be John's age and S be the sister's age. Notice I expressed the sister's age as John's age, because if you have two variables, you can't solve it. So for example, if I did 42 equals John's age plus the sister's age, I mean, yay, it doesn't help me. So that's the other step. Solve the equation algebraically, so you can write an equation, but you really want to just define one and try and write them all in one. Then write an equation and then solve it. And then see if it makes sense. And make sure you got the right years. So it's just 19. This is 19 years old. That's how old John is. And see if your final solution makes sense. Well, John's 10 years old. His elder sister's 4 years apart, and she's older, so she'll be 23. 19 plus 23, hey, it's 42. Makes sense. All right. So when we're building them, we've gone through some of these things before. The sum of X and 3 will be X plus 3. The cost of 2 apples, if they cost X dollars each, would be 2X. The cost of X oranges, if they cost $1.50 each, well, it would be $1.50 times how many oranges you have, $1.50X. Triple the value of X is 3X. 1 more than X is X plus 1. We've solved some of these. So if the cost of 4 pens is $12, well, 1 pen would be 3. So we could write an equation with where P stands the cost of each one pen. It'd be 4P equals 12, which would be this one. So that would be your equation that you would use to set it up, because you've got to define P. P stands for the cost. So we've got 4 times the cost of a pen has to equal 12, and you can divide them by 4. Josh's age next year is 10. His current age is J. So it'd be J plus 1 equals 10, because that's his current age is J. The cost of N pencils is $10. Each pencil costs $2. So the cost of N pencils is $10. So it'll be N, and each pencil, so it'll be N divided by 10. It'll be 10 divided by 10N. Would it be 10N divided by 10 equals 2, or would it be 10N equals 2, or 2N equals 10? Well, it'd actually be 2N equals 10. The cost of each pen is 2, where N stands for the cost of the pencils. N times 2 equals 10, so it'll be 5. Solve the following equations. We've done that before. So when we're working through some of these problems, and they do get pretty tricky, we can work. Solving equations is probably the hardest part. So the weight of 6 identical blocks is 1.2 kilos. What is the weight of one block? One book. Sorry, not I thought it was a block. So we know 6. So first of all, we're going to define it. B is the weight of one book in kilograms. So we've got 6 times the weight of a book. So 6 books times the weight of one book gives you 1.2. Divide by 6 is 0.2. The cost of 8 identical toys is $24. What is the cost of one toy? So we got the cost of 8 identical toys is $8. What is the cost of one toy? So let's do X equals cost. Let's do C. C equals cost of one toy. So I got 8 times the cost of a toy equals 24. So my equation would be 8C equals 24. Now I can solve for C. C equals 3. $3 for one toy. So my answer would be one toy costs $3. And that's a dollar sign, not 13, by the way. Purchasing 5 apples and a $2.40 mango costs the same as purchasing 7 apples and a mandarin. Now this gets a bit trickier. So we've got 5 apples. Oh, I don't need to do this. So C stands the cost of one apple in dollars. So purchasing 5 apples, 5 times cost of one apple, and a $2.40 mango plus $2.40 mango costs the same. That's my equal sign. Costs the same as purchasing 7 apples, 7C, and a mandarin that costs 60 cents plus 6C. Now, what is the cost of one apple? Well, now I can solve it, put all my variables on one side. So I'm going to minus 5C from both sides first. That'll give me minus 0.6 to get rid of that. Divide by 2, 90 cents. I can put that back in and see if it makes sense. Let's try this one. Purchasing 4 cans of soft drinks and a $3 carton of milk costs the same as purchasing 2 cans of soft drink and a $6.40 bottle of juice. What is the cost of one soft drink? So I'm just going to snip that. All right. Okay. So first we've got to define our variable. What are we trying to figure out? We're trying to find out whether it's the cost of 1 can of soft drink. So we're going to let C equal cost of 1 can of soft drink. Okay, so if we purchase 4 cans of soft drink, 4 cans, and a $3 carton of milk, it costs the same as, that's an equal sign. So here's 4C, 4 cans of soft drink and a $3 costs the same as purchasing 2 cans of soft drink and, because a $6.40 bottle of juice? What is the cost of 1 can of soft drink? So we want to solve for C. So we want to solve for C to find out what one cost is, because we've told it. So now let's minus 2C from both sides. Now let's minus 3 from both sides. Divide by 2 from both sides. $1.70. I'm going to do therefore. That's a therefore symbol. I'm answering the question. $7.70 is, yeah, I don't know if that's good or cheap. Depends, I suppose, where you buy it. The cost of 1 can of soft drink is $7, $1.70. All right, one more. Jane and Luke had a combined age of 60. Given that Jane is twice as old as Luke, find the age of Luke and Jane's age. If Jane is twice as old as Luke, so let's define a variable. Let's do L for Luke. Let L equals Luke's age. So if we've got Luke plus 2 times Luke's age, because that's Jane, notice we didn't do L plus J, we wrote Jane's age in Luke's term, that has to equal 60. So we know it's actually 3L equals 60. Divide by 3, it's 20 years. Does that make sense? If Luke's 20, Jane would be 40. All right, that adds up to a combined age of 60. Let's try it ourselves. Jamie and Lisa, I'm just going to copy this one. And this will be the last example, and then I'll let you guys go and have a crack at this one. Jamie and Lisa have a combined age of 48. Given that Lisa is 3 times as old as Jamie, find their ages. So I'm going to let J equal Jamie's age. So I know Jamie and Lisa have a, given that Lisa is 3 times as old as Jamie, so we know that Lisa equals 3 times Jamie's age. And we know, well, Jamie is just Jamie's age, and they have a combined age of 48. So therefore, her plus her, which is really J plus 3J, that has to equal 48. Now I can solve that. That's going to be 4J equals 48. I can divide by 12. 12. Let's see if that makes sense. If she's 12, and then 3 times 12 would be 36. 12 plus 36 is 48. Hey, that's correct. And then we write, therefore, find their ages. "12 years old," I'm just going to write in shorthand, and Lisa is 36 years old. Now, another way you could have done it is some people might have gone, and that would be the easier way, okay? Some people might have gone, let Al equal Lisa's age. That's fine. Al. What's Jamie's age then? So Jamie is how old? Well, if Lisa's 3 times as old as her, that means Jamie would be a third. So therefore, Jamie is a third of Al. So therefore, I know when I add them together, I'm going to have Al plus a third of Al would look like this. Al on 3 equals 48. Now, this is going to be a bit trickier, but I mean, you can still solve it. And I'm just going to show you guys how. If you add 1 and a third, that would give you 4 thirds, right? So that would be 4 thirds of Lisa equals 48. Now I'm going to multiply both sides by 3. 4 lots of 48. 3 lots of 48 is 150 minus 6. It's going to be 144. For L, divide that by 4. That would be, well, 40 would give me 10, 20 to 80, 25 to 100. 44 would be 11, so that would be 36. divide by 4 on both sides, L equals 36. So Lisa equals 36, but I know Jamie's a third of Lisa's, so a third of 36 is 12. So again, I can still get to the same answer, but that would be a bit harder. Personally, I'll try and use the younger age and then use the multiple, because otherwise if you start dealing with fractions, it does get a bit trickier. You still can get there, but it gets a bit harder. So that's those ones. If you can just give me a bit of an indication, what I'd like you to do is, obviously, if you haven't finished off the previous subchapter, please go back and finish the fluency and problem solving. Really what I'd like you to do here is actually complete every question. So 1 through to 10. Have a go at all of those. Before you go, though, if you can just give me a bit of a feedback about 0 to 5, 10, 5, yep, I understand this. I reckon I can do it pretty easily. 4, I got most of it. I'll give it a good shot. 3, I may run into some problems, but I'll probably be able to get a few of the questions. Some I won't too. Maybe 1 or 2 I might get. 1, you're going to pretty struggle. So if you can just let me know how you're going, that would be great, just to give me a bit of feedback. But that is those ones there. Good luck and have a crack at those.